Hello everyone, welcome back to the Math UMS class, week number 15. From this week, we will begin a new chapter, the Cartesian Plane. Cartesian Plane is a very powerful mathematical tool that can describe positions using numbers, and for that, it will make calculating in the space much more easier. And in the first lesson today, we will focus on the most basic, the most fundamental concepts and ideas related to the Cartesian plane. We will discuss how it is created, how it works in describing positions using numbers, and we will also describe lines on Cartesian plane as well as examine some features of a line on Cartesian plane. Okay, are you ready? Now move on to the Cartesian plane. The math that we are learning today begins with a spider. You guys remember this spider? Unfortunately, not this one, but this one. It is said that on a brilliant day, French mathematician René Descartes noticed a spider on his walls and had a brilliant idea. He thinks that I can describe the spider's exact position by saying how far it is from the side wall and how far it is from the ceiling. Can you picture that? Now look at the spider. We measure the distance from the spider to the side wall and the distance from the spider to the ceiling. Let's say it is 30 centimeters away from the side wall and 40 centimeters away from the ceiling. So the two numbers 30 and 40 combined together will give the exact position of the spider. And can you see that? Inspired by the situation, René Descartes created the coordinate plane that can describe the positions using numbers. He created a math tool to exploit the same principle, the coordinate plane. Now we call it the Cartesian plane to honor him. Cartesian is the adjective form of the word Descartes, which is his surname. And first, we need an anchor point called the origin. Next, we have two perpendicular fixed lines called the axes x and y. X is the horizontal one, while y is the vertical one. And I would like to add some information here. The origin O must be the intersection of the two lines. We have the axis x horizontally and the axis y vertically. And finally, in order to measure the distances, we should need something like rulers, right? It will be a grid of units. Here you can see that 1, 2, 3, 4, and 1, 2, 3, 4, -1, -2, -3. Actually, they are the two number lines, one horizontal number line and one vertical number line. And note that um, when we say about distances in this, I mean the both negative distance and positive distance. Negative distances often don't make sense, but in this case, you should understand that it is the number of steps that move backwards. The number of steps that move backwards. It can move backwards vertically or move backwards horizontally. So the cultists say that I have invented a convenient way to describe points, which means I can link geometry and algebra. This is a very important meaning of the Cartesian plane because when we have a difficult geometry problem, we can convert the geometry problem into the algebra problem using the Cartesian plane. It has been applied so many times, and you will see that application later. And apart from Sir Rene Descartes, I have invited Lucas the Spider, and he will accompany us in this lesson today. Now let's see how it works. We consider a point on the Cartesian plane, which is colored yellow here. First, we measure how far it is from the origin. It is 2 units horizontally, and it moves to the positive side. 1 unit vertically. Of course, it is above the origin, so it is a positive 1 unit. And we write 2, 1. We call that the coordinate of the point. The horizontal distance, in this case 2, is called the x-coordinate. The vertical distance, in this case 1, is called the y-coordinate. Can you see that? The x-coordinate is the number of units that move to the right horizontally, and the y-coordinate is the number of units that move to move upwards vertically. When we move down, actually, we can consider that we move upwards negative units. Okay, that's how the coordinate works. We write the positions as a pair of numbers in order, always in order. The x coordinate first and y coordinate second. And now try writing the positions of other points. I have shown you 3 other points. Now you should pause the video and try to name the coordinates yourself before begin the video and see the answer. Okay, have you got it? Let's see the answer. In the first point, we have it moves 3 units to the right from the origin, and it moves downward 1 unit. So the x coordinate is 3 and the y coordinate is -1. Combined together, we have the ordered pair 3 and -1. The coordinate for the second point is -1 and -2 because it moves negative. It moves 1 unit to the negative side and it moves 2 units downwards. Remember that always the x coordinate first and y coordinate second. Finally, we have this point -1 and 3. Okay, have you all got the correct answers? I hope so. Now we begin with a very interesting and very important concept in Cartesian plane, which is line. To begin with, we consider the points x, y satisfying the equation -2x plus y equals 1. There are a lot of points that have the coordinates satisfying the equation, but first we will begin with some basic ones. If x is 0, then y is 1. We have a01 is a point that satisfies the equation. If x is 1, then y is 3. We have b13. If x is -1, y is -1. Then we have x is -1 and -1. Now we will plot the 3 points on the Cartesian plane. Like this. What can you tell about their positions? Do you notice something special about their positioning? Yes, they are all aligned. You can see that they belong to one single line. Now, can you make a prediction on the position of the point D25, knowing that 25 satisfies the equation -2x plus y equals 1? Can you guess? Yes, you can, right? D25 also falls onto the line. because it satisfies the equation negative 2x plus y equals 1. And now you should realize that all the points that satisfy the equation negative 2x plus 1 equals 1 form a line. And the equation negative 2x plus 1 equals 1 is called the equation of the line. It is like another name for the line. It is like the identification for the line. And generally, we have a very important claim. Every line in Cartesian plane is determined by an equation of the form ax plus by equals c. Vice versa, any equation of the form ax plus by equals c determines a line in Cartesian plane. So it means that if I have a line, then I can find its equation. And if you give me an equation, I can generate a line. Now we have an example. Plot the line ax minus y equals 2. In order to plot the line, we need at least 2 points that satisfy the equation. You know that 2 points will determine a line, right? But I suggest plotting 3 points for better accuracy. If x is 0, then y is negative 2. We have a 0, negative 2. If x is 1, y is 0, then b is 1, 0. If x is 2, y is 2, we have c 2, 2. Now we have 3 points. Of course, they are all aligned. And by connecting the points, we have the line defined by the equation 2x minus y equals 2. See? Can you get the idea now? The next section, we will discuss about some features of a line. Now we examine some features of a line in Cartesian plane. There are the x-intercept, y-intercept, the gradient of a line, and parallel and perpendicular lines. First, the x-intercept is the value of x when y is 0. Similarly, y-intercept is the value of y when x is 0. So if we give x the value of 0, we can calculate the value of y is 1. So y should be the y-intercept of the line. The x-intercept is negative 2. You can see that the x and y intercepts are actually the coordinates of the points that um, are the positions where the line passes through the axis. Can you see that? The y-intercept is where the line passes through OY, and the x-intercept is where the line passes through the OX. Can you see that? Next, gradient of a line. Gradient or slope of a line is a measurement of steepness. Let's take 2 points belonging to the line x1, y1 and x2, y2. Then the gradient is calculated by the formula the y step divided by the x step. The y step means the change in the y coordinate, and the x step is the change in the x coordinate. We take y step divided by the x step. And more specific or more explicit, it is y2 minus y1 divided by x2 minus x1. Now let's try calculating the gradient of the line on the screen. We take 2 points on the line, A 4, 3 and B 0, 1. The y step is ya minus yb. It is 3 minus 1. And the x step is xa minus xb. It is 4 minus 0. So the gradient should be 2 over 4 and we can reduce it to 1 over 2. So we know that the gradient of the line is 1 over 2. The gradient of a line has a very important meaning that describes the line. It shows whether it is steep or flat, whether it goes dramatically upwards or just move a little bit from the horizontal level, something like that. It is a measurement of steepness. And finally, we have the concepts of parallel and perpendicular lines. Two parallel lines will have the same gradient on Cartesian plane. You remember, two parallel lines are lines which have no common points. And they always maintain the same distance in any position of the two lines. So I will draw another line which is parallel to D1. It is D2. You can calculate that the gradient of it is also 1 over 2. The two parallel lines have the same gradient. Can you see that? How about two perpendiculars? It is more complicated when we try to confirm two lines are perpendicular to each other. Two perpendicular lines gradients have product equal -1. For example, the given D1 line has the gradient of 1 over 2. So if there is a line which is perpendicular to it, it must have the gradient x that when multiplied by 1 over 2, it gives the product of -1. Can you find any value that when multiplied by 1 over 2, it will give the product -1? Yeah, that's right. It is -2 over 1. So we have the D2 which has the gradient -2 over 1, and it is perpendicular to the given D1. Can you see the idea now? Now let's have some example. Consider the line D, and we should plot the line on Cartesian plane, determine the x-intercept, the y-intercept, and the gradient of a line. After that, we should answer the two questions. Is D2 parallel or perpendicular to D? Is D3 parallel or perpendicular to D? Okay. First we find the x-intercept and y-intercept. Actually, we should find the x-intercept and y-intercept first, and then we can connect the 2 points of the intercepts to form the line. It should be more convenient. If x is 0, then y is 3, the y-intercept is 3. If y is 0, then x is 3, the x-intercept is also 0, or is also 3. Okay, continue with the gradient of the line D. It is y step divided by x step, and it should be yb minus ya divided by xb minus xb minus xa. Continue with calculating the gradient of D. It should be equal to y step divided by the x step. It is yb minus ya divided by xb minus xa, and it is 0 minus 3 divided by 3 minus 0, and it should be equals to -1. So the gradient of the line x plus y equals 3 is -1. And from this problem, we will have a very useful tip to quickly calculate the gradient of a line. It is the opposite of y-intercept divided by the x-intercept. Remember that y-intercept divided by x-intercept and add the minus sign before the result. Okay, now let's have some practice. Let be given dy 2x minus 3y equals 3. Find the x-intercept and y-intercept of the line. Determine the gradient of the line. Find m such that the line mx minus m plus 2y is equal to 2 is parallel to D. Okay. Now first we try to calculate the x-intercept and y-intercept. X is 0, y is negative 1, y-intercept is negative 1. Y is 0, x is 3 over 2, so x-intercept is 3 over 2. The gradient is the opposite of y-intercept divided by x-intercept. It is minus negative 1 divided by 3 over 2, and it is 2 over 3. Okay, the y-intercept. The gradient is 2 over 3. Now we need to find the value of m so that the line is parallel to D. First, we need to calculate the gradient of that line. If x is 0, then y is equal to negative 2 divided by m plus 2. Of course, we assume that m is different from negative 2, so that the fraction will make sense. If y is 0, then x is 2 divided by m. Because the two lines are parallel, so the gradient of the two lines must be the same. The gradient of the line is y step divided by x step, and it is m divided by m plus 2. And because it needs to be equal to the gradient of the given line D, so m divided by m plus 2 must be equal to 2 over 3. And that gives m equals 4. So m equals 4 is the desired value for m. Have you got it? Okay, that's it for today. That's all of the lesson today. I hope that you will get along really well with the new concept of the Cartesian plane. And before we end this lesson, I would like to announce the winner of the Octopus game number 2. Remember the round 2 of the Octopus game? Where's Perry? And the winner of our round 2 in Octopus game is Nguyễn Minh Ngọc. Congratulations to Nguyễn Minh Ngọc from class 8A3, I believe. She is the winner of the round with the fastest submission for the correct answer. The correct position of Perry is G4. I see a lot of you have the correct position of Perry, but Minh was the fastest. So again, congratulations to Minh. I will contact you and try to give you the present. Okay, that's it for today. Thank you very much for your attention. See you next week.